So these three problems I have taken from SC Burma and we are going to solve these problems. Okay. These are very simple problems. This requires the application of the formula that we have learned in the class in the chapter ray optics. Okay. So the first problem I'm going to solve this problem. You can read the question. Question number 48 we can solve. This question number 48 first I'm going to solve. Or 37. Any question we can solve first. Let us solve this question number 48. So it is written there a convex lens has focal length 25 centimeter. So first we will write down the data. What is the data given? So first the double convex lens is given. Convex lens has positive focal length. So focal length f is given. It will be equal to plus 25 centimeter. Remember when we are solving the problems in ray optics, we need to use the sign convention also. The radius of curvature of one of the surface is double of the other. Look, this is your double convex lens. Let's see here. This is your double convex lens. Just for a minute. This is your double convex lens. Okay. Both the surfaces are convex surfaces. Okay, there will be two radius of curvature. There will be two center of curvature. Here we can define. This is the principal axis and two surfaces are there in case of double convex lens. XY is a double convex lens, then XP1Y will be first convex surface and XP2Y will be your second convex surface. You can see here. Okay, so there are two refracting surfaces, two centers will be there. Center C1 will be towards the right here. You can see because XP1Y surface, you look here, it is forming a sphere, and XP2Y, it is also forming a spherical surface. So here you can see its center is equals to, here we can take the center C2. And this distance between pole and center is known as radius of curvature. Now radius is given. Sign convention I am not using here. Radius of curvature of one surface. Suppose radius of curvature of XP1Y it is equal to R1 and radius of curvature of XP2Y it is equal to R2. Then R1 is equal to R2 it is given. Okay. A double convex lens has a focal length 25 centimeter. We have taken the radius of curvature of one of the surfaces double of the other. So I have taken R1 is equal to 2R2. If the refractive index of the material of the lens is, find the radii, this radii we need to find out. If the refractive index of material of lens is 1.5. So refractive index of material of lens, suppose we are representing by symbol mu2, it is given 1.5. And again, the refractive index of the medium, because the medium is not given, so we are taking air medium. Let us assume the lens is placed in air medium. So the refractive index of surrounding medium, mu1, which is represented by mu1, it is equal to how much? It is equal to 1 here. Now we can apply the lens maker formula. If it is visible to everyone, we can apply the lens maker formula. What is your lens maker formula? So here we can apply lens maker formula. Applying lens maker formula. I am only giving you the idea. Next step you need to solve. Applying lens maker formula. If you will apply the lens maker formula, what is lens maker formula? The lens maker formula is 1 upon f equals to 1 upon f equals to mu2 by mu1 minus 1 multiplied with 1 upon r1 minus 1 upon r2. Just replace the value. 1 upon f, replace the value of f. F is equal to 25. So 1 upon 25 equals to mu2 by mu1. Mu2 is given. What is mu2? Mu2 is given 1.5. Mu1 is also given. Mu1 is given 1 minus 1. 1 upon r1. You can see P1, C1. It is towards the right, so it will be positive. So I'm taking 1 upon R1. Okay. Minus 1 upon R2. R2 is towards the left, so we can take this R2 to be minus of R2 using the sign convention. Whatever value will be given. Okay. So minus of R2 we can write. Towards the left, it will be minus using sign convention. So it will become 1 upon 25 multiplied with 1.5 minus 1. It will be equals to, equals to 0.5 towards the right and it will become 1 upon R1 plus 1 upon R2. Okay, now keep on solving. So it will become 1 upon 25 equals to 0.5 multiplied with R1 is equal to 2R2. So we can write down R1 we can replace by 2R2 plus 1 upon R2. Okay, just keep on solving. So it will become how much? 2R2 plus R2, it will become 3R2. So 1 upon 25, you need to see the sign convention step only I am giving you. 0.5, it will become R2 plus 2R2 divided by 2R2 into R2. It will become 2R2 square. Just solve this, you will get the value of R2 because this equation will be in terms of R2. So you will get the value of R2 here. Once you will get the R2, you will get the R1. So R1 and R2 can be calculated. Okay, but please see the sign convention. R1 and R2, the sign of R1 and R2, we need to use it according to the sign convention. So here you can calculate R1 and R2. Very simple. Now we are moving to the next problem then. Is it clear? A very simple problem. We have just applied the lens maker formula. Is it clear? Nobody is telling me anything. अरे नहीं put करेंगे तुम लोग क्या डर गए? I will not put there. I am just solving only. You can reply. Is it clear? Or not visible?
Yes, sir.
Yeah, tell me then. Look at question number 37 I'm solving here then. You can see here, question number 37. This question number 37. Locate the image formed by the refraction in the situation shown in the figure. Look, refractive index of two medium is given. It is 1.0 and other medium it is given 1.5. Let us take this medium to be mu1. Okay. One is mu1, other is mu2. So mu1 is given. mu1 equals to 1.0 and mu2 is given. mu2 is 1.5. Okay, we need to locate the position of the image. Object distance, S is your object here. S is your object. So object distance is also given. Object distance we can represent by U. Towards the left it will be minus of 25 centimeter. Okay. Radius of curvature is also given. Equal to radius. Radius of curvature. R is given. Towards the right it will be plus. So plus 20 centimeter. Okay. Then what we need to find out? We need to find out the position of image. Once you will find out the position of image, you can easily locate the position of image also. So this formula we can apply. Refraction through a spherical surface. Okay. Refraction through a spherical surface. Okay. A spherical surface. So light is placed in a medium having refractive index mu1. So this formula we need to apply. Light is traveling from mu1 to mu2. Medium 1 to medium 2 it is traveling. So this formula we can apply. mu2 divided by V minus mu1 divided by U. It will be equal to mu2 minus mu1 divided by R. This is the formula for refraction of light through the spherical surface. Okay. Now mu2 is given 1.5. Image distance we don't know, divided by V. Minus mu1 1. Object distance is given minus of 25 equals to mu2. Mu2 is given 1.5 minus mu1 is given, mu1 is 1.0 divided by radius. Radius is also given. Radius is 20 centimeter. Just solve it. It's very simple now. So it will become 1.5 divided by V minus plus it will become 1 by 25 equals to 1.5 minus 1. It will become 0.5 divided by 20. Okay. Just keep on solving. If you will solve this problem, then you can see here it will become 1.5 by V equals to 0.5 divided by 20 towards the right. 1 by 25 will be negative. 1 by 20. Okay, you can cross multiply. Very simple to solve the fraction. Just cross multiply. 1.5 divided by V. Yeah. 25 will be 25 will be multiplied with 0.5 minus 20 will be multiplied with 1. 20 into 1 divided by 20 into 25. Okay. You can keep yourself muted. Yeah. Now solve this. When you will solve, you will get the position of image. 1.5 divided by b equals to 25 into 0.5. So it will be 12.5 minus 20. Is it clear? 20 into 1. Yeah. Divided by 20 into 25. 20 into 25. And from here we can calculate the value of b. B will be equal to how much? 20 into 25 multiplied with 1.5 divided by 12.5 minus 20. It will become minus of 7. When you will solve, you can get 15 fives are 75, 5 into 5, 25, 25 into 5. It will be equals to 100, minus 100 centimeter. Minus 100 centimeter is telling you that the image is formed on the same side. B is equal to minus 100 centimeter. So we can locate the position of image here. Very simple. This formula I have applied. You can see. This formula I have applied. The refraction of light through a spherical surface. You can go back to the problem. This was the problem. Question number 37 you can see here. This is your question number 37. So 25 centimeter on the same side minus 100 centimeter you need to take. Here image will be. Image is okay on the same side. So position of image now we can locate. Once you will calculate the value of the image distance, we can locate the position of image. Is it clear? This problem is clear. You need to reply.
Yes, sir.
Yeah, good. So this problem also we have completed. Look, the first question, question number 48, we have used the lens formula. Okay, lens maker formula in fact. Lens maker formula we have applied. But please solve this problem and match the answer. Okay, and 49 we have not solved. Question number 37, we have used the formula of refraction of light through a spherical surface. Now, question number 49 is also based upon lens maker formula. Can we select this? Yeah, we can select. Just wait for a minute. This is your next question. Here you can see. This is your next question. Question number 40. Can you see this problem? Question number 49. Is it visible?
Yes, sir.
Yeah. So let us
Yes,
solve.
sir.
Yeah, see this problem. What is given? First, we will see the given data in this problem. Question number 49, you can see the radius of curvature of a lens are 20 centimeter. R1 is given. Let us take R1 is plus 20 centimeter. It is already given using sign convention. And second surface R2 is also given plus 30 centimeter. Can you tell me the type of lens? Anyone from the class? Concavo convex. Good. Because both the radius are same, I've told you. Concavo convex R1. Like this surface. Okay. This will be your concave and this will be your convex. Then both the center will be towards the right. So radius R1 and R2 will be positive. Very good. Concavo convex lens it will be. Now the material of the lens has a refractive index 1.6. So mu2 is given. Refractive index of material of lens is given. mu2 is equal to 1.6. Find the focal length of the lens if it is placed in air. Question number A. If it is placed in air, what will be the refractive index of medium? mu1 will be equals to 1. Then what is the focal length? We can calculate using lens maker formula 1 upon f equals to mu2 by mu1 minus 1 into 1 upon r1 minus 1 upon r2. Easily we can solve. All the values are given. Just you need to put the value, you will get the answer. 1.6 divided by 1 minus 1. 1 upon R1, R1 is given 20, R2 is given how much? It is given 30. Solve it. When you will solve, you will get the answer focal length. How much you will get? 1.6 minus 1, 0.6, and 30 minus 20, it will become 10 divided by 30 into 20, it will become 600. 0, 0 cancel. Okay, so it will become 0.6 divided by 60. So 1 upon F equals to 0.6 by 60. So when you will take the reciprocal, then F will become 60 divided by 0.6. Okay, so it will become 100 centimeter. Okay, focal length will become 100 centimeter. 6 into 10, 60. And one decimal is there, so it will go in numerator. So 10 will be multiplied. So 10 into 10, it will become 100 centimeter. So this is the first case. The second case is if it is placed in water. Just see here what will be the focal length. So B is given. When it is placed in water, now the surrounding medium will have the refractive index 1.33. Then what will be the focal length? We can use this formula. 1 upon F is equal to mu2 by mu1 minus 1 into 1 upon R1 minus 1 upon R2. Just use the formula. Put the value. Mu2 is always fixed 1.6. Only we have changed the surrounding medium. Now surrounding medium is water. So 1.33 minus 1 into 1 upon R1 minus 1 upon R2. R1 is 20 and R2 is 30. Now you can solve, you will get the focal length. Different value of focal length you will get.